Okay, so I'm gonna try to make this short. I've had to try to pare down what's in this lecture. There's so much we could talk about in terms of aerobic training. So um, I'll get through what I can. I wanted to start with reviewing some of what we've talked about in the past. So first, we've got these health-based markers of fitness, and then um, I want to briefly talk about the paper we talked about. So just make sure that you're aware of what these four things are. Remember that this one includes endurance and strength, and make sure that you're familiar with different ways to measure them. And then also be familiar with these principles. I'm not quite as concerned about this side just because this isn't a physiology class. So we'll do some with this, but not as much as we will with sort of these general programming principles. Um, Also remember FitVP, make sure that you're familiar with all of those principles, how they're defined and measured. And then know that I will be posting this video as well as your exercise demonstrations and your 10-minute lessons. Um, uh, I'll be posting these now, and then your 10-minute sort of movement demonstrations are going to be due, I think, Friday at midnight. So I'll post those as soon as you upload them to Canvas. Okay, so we're going to talk about aerobic training. Generally, there are three adaptations that we're looking for with aerobic training. So a change in aerobic capacity, and that's what we're going to mainly focus on. That would be my body's ability to utilize oxygen maximally when relying predominantly on aerobic energy systems. We also have long duration submaximal work, and we're going to talk a little bit about that with lactate threshold. That's essentially my body's ability to maintain a given pace of exercise for a long period of time that is submaximal, right? If I'm close to max, we know that I probably can't last very long. There is a point called maximal lactate steady state, below which we can typically maintain exercise for a long period of time. And then we've got anaerobic capacity. And anaerobic capacity, right, we're referring more to sprint style movements. And that could be anything probably from about 5 minutes or less. General aerobic training guidelines are 3 to 5 days a week. So that's my frequency, 20 to 60 minutes, depending on intensity. And intensity is generally 40 to 89% of your heart rate reserve. And we'll go into that in a moment. Before we do that, aerobic capacity is measured with an estimation of VO2 max, generally speaking. So we've got a list of different tests here, and we're going to perform some of them in class next week, I believe. So just to give you a sense for what it's like to perform them yourselves, to talk someone else through performing them, and then how to interpret them as well. So one that first, sorry, heart rate max. So a lot of these equations require that you calculate someone's heart rate max. The appropriate equation is the Tanaka equation. There are lots of them, but what you'll see sometimes is 220 minus age. That's not appropriate, especially for individuals 40 years and above. So for most populations, I would say 208 minus 0.7 times age gives us a pretty good estimation for any one of these tests. Okay. Given that, so the Queen's College step test will probably do as well as the Rockport 1 mile. The Queen College step test, I set up a box at a given height, and I have somebody step up and down at a given rhythm for 3 minutes. At the end of the 3 minutes, I have them measure their heart rate, and then I plug that heart rate into this equation. Okay, you can see how it's different from males and females. The Rockport 1 mile is how quickly can you walk 1 mile? So in talking about the FIT principle, the type of exercise, so VO2 max is type or activity dependent, meaning my VO2 max, if I measure it via walking versus via cycling, is going to be quite different. So in this case, the Rockport 1 mile was designed to be walked. Even if you're a really fit individual, you should be walking for that. The Cooper 1.5 is how quickly can you complete 1.5 miles? And you can see the only variable we need there is time. 12-minute walk run is I'm max as hard as I can. I'm going for 12 minutes, and then I just see how much distance I can cover. For the 6-minute walk, it's the same thing, usually used in more frail and elderly individuals. And then we have a no measurement estimation, meaning I can literally just put in someone's age and guess what their VO2 max might be. That should give you a hint that as I age, I would expect my VO2 max to decrease. Okay, I would also expect my heart rate max to decrease with age. Okay, so a couple of options here. Then we take whatever that estimation is and we put it into this, we compare it to standard values. So these are values based on a Canadian research study, but I think it was like 4,000 individuals, maybe. It might have been bigger. I think 4,000 was for muscular fitness. I think this was like a 10,000 person study. So it's how you fit compared to other individuals. Note though that this was treadmill-based cardiorespiratory fitness testing. Um, Also note that it's age-based. So, right, every 10 years I've got a new category. Okay, so then we take whatever value we calculated here, we go over to here and we can classify our cardiorespiratory fitness as superior, excellent, good, fair, poor, or very poor. And again, separated between males and females. Okay, so we've got our value. Maybe my value was poor and I want to improve my cardiorespiratory fitness. So what do I need to do to improve that? This study looked at variables that are most likely to change your cardiorespiratory fitness. So age was the first one, and this shows whether or not it was a positive or a negative correlation. So age showed a positive correlation. So as I increase in age, actually my chances of improving my VO2 max go up. One of the reasons this might be the case is that as we age, we become more sedentary, but our body's capacity to adapt still exists. So we've deconditioned ourselves so much. So we're so low fit as we age that actually starting exercise, I'm much more likely to experience improvement. Another thing that significantly influenced this was, oh, I will say, note the age range here. It was 60 to 85. So we are working with an older population in general. The average length was 8 to 52 weeks, and increased length, so 2 months to a year. With increased program intervention, we saw improved adaptation. So the longer that you do something or stick with something, the more likely you are to have adaptation. Frequency showed a negative correlation, interestingly. So they were anywhere from 1 to 5 days. Um, One of the reasons this could be the case is it could be intensity dependent. So if I'm working out 5 days a week aerobically, especially at higher intensities, I may not be giving my body enough time to rest and adapt to the stimulus that I've given it. Okay. But that's an interesting finding here. Duration also showed a negative association. So as duration increased, VO2 max adaptation actually decreased. Also not what we would expect, generally speaking. So sort of an interesting finding here. And then intensity showed a positive association. So of the variables listed here, right, length of time, so not time of an individual exercise session, but length of an intervention. So that's that consistency piece that I sort of said was really important. So consistency seems to be pretty important. And then intensity seems to be pretty important in terms of improving VO2 max, whereas frequency and duration actually don't seem to be quite as critical, at least in an older population. There are lots of ways to adjust intensity. This article just gives us some idea about what we could expect in terms of change in VO2 as a result of how we train. And so you can see that we want higher intensity if we want VO2 max to change, generally speaking. They also did, though, recommend higher duration and higher frequency and higher length of time. So interesting that they saw these associations, and sort of their recommendations don't necessarily support that, despite the fact that other research literature would support these recommendations. Okay, so there's lots of ways to prescribe intensity, and I'm just going to take us through a couple. So we would have something that's the least individualized. So percent heart rate max is often estimated, as is percent VO2 max, rather than actually measured. And so that wouldn't be a super individualized method. The other problem with a VO2 max or a heart rate max prescription is that what's happening metabolically, so what's happening in the body, right, would be the most individualized adaptation, right? We want to know what's happening inside someone. And what we see with, and I'll get to threshold-based prescriptions, but what we see is that VO2 max and heart rate max vary a lot when we come to metabolic or threshold prescriptions. So we'll say ventilatory thresholds, there are two of them, generally speaking. Not generally, there are two ventilatory thresholds. And ventilatory threshold 1 occurs anywhere between 30 and 80% of heart rate max in individuals. So there's this huge variability. So heart rate might not necessarily match up with what's happening metabolically, which is why we would say that's not super individualized. METs we're going to go over later, but METs are an objective absolute measure of intensity. So METs don't differ across individuals, which we know that's not super individualized because I could have a 20-year-old who's an athlete at a Division 1, university, walk on a treadmill at 4 miles per hour and they're going to feel nothing, right? It won't be tough for them at all. But if I took a 60 or 70-year-old male who's unfit and I had them walk on a treadmill for 4 miles per hour, they're immediately going to start having sort of a stimulus from exercise. So METS does not differentiate between those two. It would say, okay, walking at 4 miles per hour is, let's just say it's a 5 MET activity. And it would classify that as moderate intensity. Where in reality, for the athlete, it's light intensity. And for the older individual, it's maybe vigorous intensity. Okay. So METs aren't super individualized there. Then we have a percent of VO2 reserve or heart rate reserve. Those are a little more individualized. There's a little more research backing that prescription as opposed to maximal values, just going off of a percentage of maximal values. So those take into account resting heart rate and resting VO2. So that's more helpful. We're getting there. We also use RPE at this point, and I'll get more into this in the next slide, RPE. But RPE is just your rating of perceived exertion for how difficult something is. So it's totally subjective. But because it's subjective, it's also very individualized. It's someone telling you what their personal experience is. And then the most individualized would be threshold-based training because that is indicative of what's happening metabolically speaking. And that is typically done with lactate or ventilatory thresholds, and we'll get to those a little bit later on. Oh, I did want to say, so this is in the slide notes, but there's some research suggesting that there are responders and non-responders to exercise. In sort of follow-up literature, what we see is actually there aren't responders and non-responders. There are just less and more individualized programs. So actually, if we individualize programs based on thresholds, one of our old professors who he used to work here actually did a study that was threshold based and they found no non-responders. Whereas in many studies, we find if we give everyone the same protocol, we have some people who don't respond and some people who respond really well to a given intervention. But if it's more individualized, we typically see that everyone does respond. Okay, so now I'm going to go through intensities just a bit more. So I like these descriptions. I'm not going to read through them, but this is a helpful graphic for you. So being sedentary is less than 1.6 METs. 1 MET is considered rest. So that's the amount of, so the actual number is 3.5 milliliters of oxygen are consumed per kilogram of body mass per minute at rest. Okay, that's what 1 MET is. Similarly, at rest, generally I would be at about 40% of my heart rate max, 20% of my heart rate reserve, and 20% of my VO2 max. Okay, so I am still, in fact, yes, utilizing oxygen at rest or in really light activities. There are 2 RPE scales here. So one is a 6 to 20 scale. That's this top one. Okay, the bottom one is a 1 to 10 scale. Okay, so it's helpful if you were going to use RPE to prescribe. This is a really helpful graphic, which is why it's on here. So then we move into light intensity, and you can see we've got sort of these objective measures. In subjective measures, so objective means they're not open to individual interpretation. And then subjective is they are about the individual's experience, okay? And we see these change. So 8 to 10 out of 20, remember, and 1 to 2 out of 10 here. We get to moderate intensity. Now we're at 11 to 13, 3 to 4, vigorous, 14 to 16, or a 5 to 6, high, greater than or equal to 17, and greater than or equal to 7. These are not perfect measures, and I don't know that I necessarily agree with them all the time, but it's a good starting point for prescribing, especially if you're going to prescribe using these subjective measures. Okay, if you want to prescribe exercise using more objective measures, these are also good starting points, and they match up pretty closely with what ACSM recommends. Okay, so assuming I prescribe intensity correctly, I want to know what can I expect in terms of change. So this was a really great study that was published in 2024 looking at the effect of aerobic versus resistance training on VO2 max. And I just basically wanted you to look down these rows and look at what the range is here. So in aerobic training, we see anywhere from like a 0.6 change all the way up to a 10.7 change. And I think these interventions were 4 to 16 weeks long. Okay, so I'm not going to tell somebody that their VO2 max is going to change by, 15 points. That's just not, it's not realistic. Okay, so I want to give people realistic expectations. I would say, okay, in a 4-month period, if we're training pretty regularly, I would think that like a 7 mLs per kg per minute change, or about 2 MET change, is a realistic goal if we're training really well. If I'm doing some type of resistance training that I think might improve VO2 max, right, it gets my breathing rate up, I would say now a reasonable expectation might be something more close to like 1 ml per kg per minute, which is less than 1 MET change in capacity. Okay, so just thinking about giving people realistic expectations. Okay, now we're going to get into lactate threshold changes, and I promise we'll come back to some of these values, and you'll have a chance to ask questions. And please, as I'm going, if you had questions, make comments on the video so I can come back in and sort of further explain or know what I need to address next week. This is just designed to also help us understand that, yes, everything I presented beforehand is more focused on sort of general population, but general population I would expect is to be a little more sedentary. Note that you shouldn't be expecting the same things if you're working with a trained population. So this is, sorry, I don't know why I'm yawning a lot. Okay, so what this is representing, so intensity on the x-axis, so VO2 or heart rate. What this is saying is that actually with training, so with training represented by the red line, that with training, I would expect to see an improvement in like my heart rate max or my VO2 max, okay? So if I were performing a test, we're saying the test without training, so my pre-test ended here, okay? At some value, some blood lactate and some value, right? Now with training, what we're saying is that now my test ended here, so my VO2 max is actually higher, or my heart rate max might be higher with training. Now, in reality, we don't see typically a lot of changes with heart rate max, but possible. So we see that changes. What also changes, though, is this little line here, okay? So if we look at blood lactate concentrations used to start to increase. So before we trained, they started to increase at this value, right? So let's say this VO2 max was 20 mLs per kg per minute. With training, though, now my blood lactate levels don't start to rise until I hit, let's say, 30 mLs per kg per minute. Now, what that means is that I can sustain this level, this 30 mLs per kg per minute, I can sustain that for longer. So remember how I said that walking at 4 miles per hour on a treadmill is like a 4 MET activity, okay? Or I think I said it's a 5 MET activity. Okay, so if it's a 5 MET activity, if I multiply my METs by 3.5, I get my VO2 max. So that would be whatever that is, 15, 16, like 17.5 mLs per kg per minute. So let's say that's where I was here, that walking at 4 miles per hour, I could barely maintain that 17.5 mLs per kg per minute, but I could maintain it without my blood lactate going crazy. However, with training, now I can maintain that a higher level of intensity for a longer period. So now I might be able to maintain walking at, let's say, 5 miles per hour with a 2% incline without my blood lactate levels increasing significantly. Okay. So with sedentary individuals, we have an improvement in max capacity and also an improvement at the intensity at which blood lactate increases. Now, with trained individuals, note that there's no real difference in max capacity. What there is a really big difference in, though, is the point at which blood lactate accumulation increases. And for performance, you can see how that would really matter. So VO2 max might not matter so much, but the moment that, so we have the onset of blood lactate accumulation, sometimes people will call it OBLA. If I can change that, I could likely change performance. Okay. And so you can see that that's sort of the expectation in trained individuals. So depending on who I'm working with a sedentary population, I might want to measure cardiorespiratory fitness or VO2 max. With a trained population, I might not be as concerned about that. Sorry, with an endurance trained population, not necessarily resistance trained. Okay. So that's what we have going on here. So you shouldn't train general population, or you shouldn't measure at least fitness in general population the same way you do in the athlete population. The last thing I want to jump into before we do a little bit of math is traditional versus concurrent, concurrent training versus circuit or hybrid training. So resistance training can result in improvements in VO2 max, but we would typically expect that. Sorry, my throat's getting a little dry. We would typically expect that more in concurrent training, partly because concurrent training includes aerobic training. So concurrent training would mean that I would be training resistance on a Monday and then aerobics on a Tuesday, or resistance in the morning and then like I got a 6 to 8 hour break and then aerobics in the evening. Okay, that's traditional concurrent training. And here's some examples of sort of the resistance exercises I might do. Circuit or hybrid training says I'm actually going to combine them into a single session. So I'm going to include some things like squats and push-ups. But note, like my repetition ranges are a lot different here. So I'm doing 15 repetitions, whereas over here I was doing like 2, 2, 2, 2, 2, 2, right? So what I do is pretty different. Oh, sorry, these were sets. These were sets, these are repetitions. Although I will say typically in traditional concurrent, it is a little different. But here I'm doing really high repetitions. We've got 200-meter sprints involved, right? So I would expect my breathing rate to go up a lot more with this than I would with this. Whereas here, I'm probably expecting one set followed by rest. Whereas here, I'm not expecting that. I'm doing squats followed by push-ups, followed immediately by lunges and then planks and then sprints and then mountain climbers and then leg drops, okay? So I would expect more of a change with circuit or hybrid training. I will say both training modes seem to be, generally when I look at the literature, they seem to be similarly effective, actually. Doesn't seem like there's a significant difference in aerobic capacity changes between the two types of training. Okay. I'm going to run you through this math. I won't make you do this math, but I do want you to understand it. So when we're measuring volume of physical activity, it's inextricably tied to time and intensity. So how long I do something and how intensely I do something. A common measurement uses 11.25 Met hours per week. This equates to about 675 Met minutes per week. And ACSM recommends 500 to 1,000. Okay, so I sort of put us right in the middle of what ACSM recommends here in terms of volume. So you'll see this in research papers that you read, Met hours per week. To convert to Met minutes per week, I multiply by 60. So now I've got 675 Met minutes per week. Okay. If I break that down, yoga, if I look at Mets, is a 2.5 Met activity. Okay, so it's relatively low. It's more than resting. Resting would be a 1 Met activity. Yoga's well above resting, but still fairly light intensity. Generally speaking, I would say light intensity is anything below about 3 Mets. Okay, so we're at light intensity here. In order to hit 675 MET minutes per week, I would need to engage in 270 minutes of yoga. Now, if I'm walking at 4 miles per hour, a 5 MET activity, I would need to do that for 135 minutes per week. And if I'm running, I would need to do that for 69 minutes. Running at 6 miles per hour, I need to do that for 69 minutes per week. Notice, like we were talking about earlier, frequency might not matter here. So I could do this all in one single session, or I could break that up. Let's say it's 135 minutes. I want to do it 5 different times. That would be what? 227? Is that right? Yeah, so I would do 27 minutes of walking 5 days a week. That would cover me here. And I would be meeting this goal, right? Which sets me right in the ACSM recommendations. Okay. So this is the total amount of time needed at this intensity to achieve this goal. Okay. Now, remember I said 1 MET is equal to 3.5 mLs per kg per minute. So a 5 MET activity, this walking activity, is 17.5 mLs per kg per minute. That's the amount of oxygen that I'm going to utilize while engaging in that activity. Okay. We're going to skip that and jump right into this. So I can calculate the number of calories that I will utilize based on the intensity of the activity and how long I do it for. Okay, so note though that it is body weight and activity specific. So we know that walking at 5 METs, or sorry, what is it? What are we at? We're walking at 4 miles per hour. Okay, so that's a 5 MET activity, requires 17.5 mLs per kg per minute. I'm going to convert that. So I'm going to convert my milliliters to liters. And then we know that it takes about 5 calories to process 1 liter of oxygen. Okay. So for that activity, it takes 0.0875 calories per kilogram of body weight per minute to engage in that activity. So I'm going to multiply by body weight. And now I used my body weight, so 165 pounds. I divided that by 2.2 to get 74.84 kilograms. Okay, so then I have 74.84 kilograms. I multiply by that number, that 0.0875, to get walking at 4 miles per hour. Someone my size, is going to utilize 6.5485 calories per minute. Then we said to meet that goal of 675 MET minutes per week, I needed to do that for 135 minutes. So if I multiply that by 135 minutes, I'm going to utilize 884 calories per week. Okay. I wanted you to sort of follow that just so that you understand how calories are calculated, and also so that you understand how sort of if someone's wearing an activity tracker, it has to be, that's why like Apple Watches will ask you, what activity are you doing? Because the activity determines the intensity. Okay. Then it will measure how long you do it for. It knows your body weight, and so it can estimate the total number of calories utilized. Okay. Now, I will say one of the problems with this is that actually this 3.5 mLs per kg per minute is not accurate. So it's based on some old research that nobody seems to be able to find anymore. I've looked for it. I can't find it either. And I mean nobody in like across the scientific spectrum. We don't know, and we don't know why we're still using that number. It really is sort of confusing to me, because the study has been redone multiple times, and it looks like the baseline amount of oxygen used at rest is closer to 2.5 milliliters of oxygen per kilogram of mass per minute. Okay, that would take my 884 calories and drop it to 631 calories. So 253 calorie difference. Okay, now I'm going to show you that sort of across a range of activities. So as intensity goes up, that difference becomes greater and greater. So if I'm engaging in soccer, right, and I'm assuming that I'm utilizing 3.5 mLs per kg per minute at rest, and then I'm multiplying that by soccer is 10 METs, right, across a certain period of time, now that difference is 225 calories. in a single, is that a single? It's not a single minute. I think this is based off of, I should go double check my numbers. Oh, I think this is based off of 60 minutes of this activity, if I remember right. I'll go double check. But across 60 minutes, I now have a 225 calorie deficit that I need to make up. So my watch is telling me, hey, you've burned 787 calories, when in reality you've burned 562. So if I'm tracking my calories as an individual and I want to lose weight, right? I'm now off by 225 calories in a single activity, right? If I did that activity 3 times during the week, okay, now I'm off by 675 calories, right? And if I do that for 4 weeks, let's say, and I'm expecting weight loss to happen, now I'm off by whatever that is, like 2,500-ish calories, okay? So there are issues with the way that calories are tracked. But I wanted you to understand METs and how they're utilized and how your clients are likely getting data off of their wearables. So it's pretty common that wearables are off by about 20% in terms of their estimation for your calorie consumption. And I wanted you to understand why that's the case. Additionally, and this is where I'll end for today, and then we'll do some muscular fitness stuff next week. But the other thing to sort of think about, excuse me, is this question: are calories accurate? So tracking calories is an effective way to lose weight. However, and we'll probably do a weight loss section later this semester at some point, but um, calories on food labels are allowed to be off by as much as 25%. So they might not be super accurate. Additionally, what your watch is telling you also might not be accurate. So you can see how those two compound each other. And if I'm tracking calories, I might be really off. So I will say, as you're working with individuals, especially if they have a weight loss goal, I would highly encourage them to be tracking their weight. And if they want to track calories, great. But make sure that okay, you're looking at a 500 calorie deficit every day, let's say. 250 are through exercise and then 250 are through your diet. Okay. That's great. 500 calorie deficit across 7 days. I would expect to be losing about a pound a week. Okay. That's pretty standard. We typically expect about 3,500 calories to result in a pound of weight loss. Okay. And some of that can come from exercise and some of that can come from diet. Totally fine. But if they're achieving that through tracking their calories, right? If we say, hey, I want you to eat 250 calories less per day, they need to be tracking calories. Otherwise, I don't know if they're eating 250 calories less per day. In any case, if they are doing that, and then we track that across, let's say I'd give them at least 2 weeks and I don't see any weight loss, to me, that would indicate, ooh, okay, that level of calorie consumption, whatever you're eating at home, that might be off, or the watch is telling you that we're burning more calories than we are. Okay, so we need to actually either increase calories on the watch or decrease calories that you're eating at home. Okay. Hopefully that gives you a little bit of context for aerobic activity and aerobic training. I thought there was one other slide. Oh, there is one other slide that I wanted to include. Yeah, I'll end here. I don't know why it's out of order. Um, so you can see how when we were calculating METs, right? We looked at a 5 MET activity done for 135 minutes. That's 884 calories per week. That would be more what I would think of as sort of long, slow, low intensity work for most people. Okay, walking at 4 miles per hour. Maybe I split that up into 5 sessions, which we'd say is 27 minutes per session walking for 4 miles per hour. Okay, pretty doable, feels reasonable. The other type of aerobic training that's pretty common now, especially, is high intensity interval training. This is a great way to prescribe exercise, which is why I give you this handout. Note the intensities that they use. So 170% of VO2 max. We can talk about why you can get above VO2 max at a different time, but these are 20-second bursts, okay, followed by a 10-second rest repeated 8 times for a total of 4 minutes. That's an excellent workout, Okay. You have something like the Wingate protocol. I don't recommend it a lot, but that is absolute max. You need to be exhausted at the end of 30 seconds. Here we've got 90% heart rate reserve. Okay. And we can talk about, again, if you really want to know how to calculate these things, I'm happy to teach you. It's not difficult. And then we've got clinical. So 4 minutes of 85 to 95% of your max heart rate, and then 3 minutes of 60 to 70% of your max heart rate repeated 4 times for a total of that's 27 minutes. Don't know why it says 25. Um, so you could still calculate calorie consumption for these and intensity for these. It's a little more difficult, right? Because I need to calculate it separately for each of those intervals and what met value I might be at for every individual interval. But you could absolutely do it, and I can run you through how to if it's something that you're interested in. Okay, I just wanted to give us a sense for what aerobic training is. Note, if we come back to the recommendations, just getting pretty basic, the recommendation is 3 to 5 times a week for 20 to 60 minutes a day, lower if it's high intensity, longer if it's um, moderate intensity. And a decent rule of thumb is 40 to 89% of their heart rate reserve. Okay. Note that would put them anywhere from light all the way up to vigorous. So if I'm using RPE, anywhere from about a 1 to a 6 on a 1 to 10 scale. Okay. I would then expect after 4 to 16 weeks, their VO2 max to change by something like 7 mLs per kg per minute or 2 mets. Okay. That's a pretty concise sort of summary on hopefully what we've just covered. Please ask questions, and I will see you next week.